Android and Android development. So just a quick background from myself. I'm currently working at TikTok in the social messaging team. So any of you is using TikTok, is watching TikTok? No one. Don't be shy. Okay, I see a few hands. Yeah. TikTok, I think, is famous for the short video. It's the first thing you see when you open the application. But our team is responsible for the messaging part, where you can share the video or talk to your friend or talk to the creator directly inside the application. So yeah, some quick background. I'm originally from France. Maybe you can spot the accent. And I graduated with a master's degree in architecture and engineering of software. And I have like 8 years of experience all in Android development. So I think Android development is not very popular topic in school. I think most of the students, when they graduated from bachelor degree or master degree, they don't do any Android at all. So just to know, like, who's familiar with Android development? As familiar, I mean, like, they created an application before. They will be able to do it if I ask them to do so. No one. Do you have Android course lesson in the university? No. Okay, then that's why I'm here. Android. So why Android? So Android is a operating system. I think most of the people are probably using iPhone with iOS. So Android is installed on many devices. It is created by Google. So today I'm going to share with you why is it interesting career opportunity maybe for you or for a software engineer. So I'm going to share with you some of the basic fundamental about how to build application for Android. So the talk will be in two parts. The talk is 2 hours, if I'm not mistaken. So the first 1 hour, it will be some slideshow with like the fundamental about Android. And the second, we'll do a break. And then after the break, I will do a live coding. I will create an application in front of you. So since I'm working in the messaging team, we are going to do the first screen of the messaging. I'm going to start from scratch, and we are going to show like the message list and like be able to add new message to a conversation or this kind of thing. Very basic. Oh, the mic just died, so it's okay. I think there's no more battery. Yeah, so overview of mobile development. So most of the users for the mobile is the primary usage for the devices now above desktop users and far above tablet users. So this is a bit outdated. So I believe now it's actually much higher. So that means that almost everyone has a smartphone. I'm sure everyone in this room currently right now have a smartphone, or maybe they are using their smartphone right now. So there's 6.4 billion smartphone user in the world as of 2021. So this is like 3 years ago. So I believe now it's much higher. And not only everyone has it, but they also spend a lot of time on it. I think it was on average 3 hours. Not sure how many hours per day the average TikTok user is watching TikTok. I think from some statistic is it's quite a lot. So we have like a lot of attention from these users. So like we are able to build some great things for the users. So I know for Singapore, iOS and iPhone is maybe the #1 by far, but that's not the case for the entire world. So for TikTok, where you are building application that is available worldwide, actually most of the user or majority of the user are coming from Android. So being an Android developer means like you will reach billion of users, especially when you're working on some company that have a product that's available worldwide. So started with version 1.0. That was quite long ago. Last version is Android 14. So 13 was in 2023, you can see the difference on the home screen. I think it has evolved quite a lot for the past 10 years. Now the new feature or the new phone are at least mostly similar as the previous one. I think the new generation of smartphone or the new version of the OS doesn't bring much improvement. I think it's pretty stable now, but there were a huge gap that was happening for the past 10 years. So now the smartphones are much more powerful than it used to be. So it allow us to do much more things for the user. So for Android, some common problem is the fragmentation. This is by the way Android was designed. It's built by Google. It's open source. You can see the entire source code. You can even try to compile, or you can modify it and create your own version of Android if you want, if it's possible. The problem is like Google, when they build the OS, they will ask the manufacturer, the device manufacturer like Samsung or Huawei, maybe not Huawei now, Xiaomi, other device manufacturer, and they will use this OS and they can use it as it is, or they can do their own modification. So Samsung, they will take it, they will create their own customization. Not sure what they do because it's not open source. Then after they will release it for their Samsung model. The problem with this is like when there's a new version of Android that is released, all the device manufacturer, they need to take this new version and they need to reapply all their changes again on the device, which is not the case for Apple because they manage the OS and also the device at the same time. So when they release a new version, they can make it available for everyone. But for Android, Google just published the release and Samsung is like, okay, maybe I will push the update. Maybe I don't push the update. It's up to them. So this process takes very long time. The problem with this is like for the new version of Android. So when we build Android application, we have access to some certain capability that is provided by the OS. So if you run your application on the latest version, you have all the latest feature. But if I want to support a lot of different version, I need to lower down the minimum version I'm supporting. For example, if I want 99% of the user being able to download my application, I need to support minimum version that is maybe from a few years ago. So this is causing some problem in the Android development, and you will see straight away later when I create the project, actually the first thing they will ask you is like, which version do you want to support and how many user this is going to impact. So this is quite a big problem from Android. I think the iOS or iOS developer, this is always the first problem they will bring for Android developer. They will say, oh, you have like so many versions to support. While for us, when there's a new iOS version, 90% of the user probably update their phone in the first few weeks. So they don't have this problem. But it's okay, we have a lot of workaround for this. So some language that we use, there is Java that is not mentioned here. Mostly we use Kotlin. For my day-to-day job, I write everything in Kotlin, which is in native. And there's also two other technology to do cross-platform, which I'm not very familiar with cross-platform, but if you are doing some hackathon or something, so you want to ship the application fast for both Android and iOS. Cross-platform means you work for both Android and iOS. It can even work on desktop sometimes, or even on some other platform. You can use Flutter, which I believe is the most famous, and the second one is React Native. React Native was built by Facebook, but I think now it's mostly out of the trend now. So yeah, you can explore Flutter if you want to build a quick application that can both work on Android and iOS. But if you want something that is with the highest performance, because one of the trade-off for the cross-platform is usually the performance, because they need to have something that can work on everything. So you work on everything, but it doesn't work very fast or very well on both. So the alternative is to do everything in native, which is mostly what I'm doing at TikTok. So the Android development. So I don't know if you got the memo. I think if you want to follow the second part and doing the coding at the same time, creating the application, you can download the Android Studio. Otherwise, you can just follow and I will show you all the steps. So Android Studio is the development software that we are using. And inside, when you download this, you have access to everything to build the application. You have the compiler, you have the development kit, the SDK, and you have even the simulator. So it looks like this. It's maybe quite scary at first. There's a lot of different sections. And actually the code, which is there in the number 3, is just one small part of the IDE. So it's actually pretty simple. You just have like on the left side, you just have all your directory where you got all your files, and then on the right you have the code. Here is a view where you also see the debugger if you want to find some bug in your program. So you set up your environment, you write your code, and there's a play button, you play, and then you automatically launch the simulator, and you should be able to see your first application, which we will do later. So the application needs, when we launch, we need a user interface. So in Android, you have two ways of making user interfaces. The first one is to write in XML, and the second is to write in Kotlin directly. So the first way, which is the one I'm going to demonstrate later, we build a view in the XML. And we define like what's the different component where, for example, in this case, we have a image view. So it's a view that is able to display image, and below we have a button. We also have a container to see how we are going to arrange all the items relative to each other, or how we are going to display in the user interface. You'll see later we will display like a list of messages. So probably we can already guess that we have like we will simplify it as like a list of text message. So we have a text, so text for the views, probably something called text view. And we will need a button, for example, for sending message. So there's probably an item called button. So I think by using common sense, you can also guess like how do we build the interface. It's supposed to be very user-friendly and intuitive. It's not rocket science. Everything is pretty straightforward. So don't be scared. The second is what we are going to discuss later is the activity. So the activity is your container of your application. It's mostly like what's going to control everything. And there you're going to set up your view and interact with your view. For example, like if I have one button, then like what's the action that is happening when I click on the button. So all of this will be defined in the activity. I put some keyword right now, and later you will see like everything will be linked to each other. So when you run your application, one of the problems that user faces, like for example, they will say like, oh, the application is slow, or like it's very laggy or something. So inside Android Studio, since it include everything, we have a profiler inside to check for like the memory usage, CPU usage for the device that are running. Even if you buy the high-end device, actually it's very constrained on the CPU and on the memory resources. So we have all the tools that are able to give us the information about what's the problem for the performance and how we can make it more optimized. I'm not going to profile later because the application we are going to build is very simple. So I believe there won't be any performance issue. The simulator, so if you are one of those person in Singapore who own an Android device, you can run the application directly on your device very easily. But if you are having an iPhone, you can install the emulator, which is already bundled inside the Android Studio, and you will have a mostly fully functional device inside your, that will be able to run on your laptop. I think if you have the latest Apple computer, which is the M1, which is the ARM architecture, since it's the same architecture as the actual device, the simulator should work way better than it used to be because all the instructions are the same. So not sure what laptop are you having right now, but if you have the latest one, everything should run super smoothly, and you will have almost like a same performance as the device that you have in your pocket. So now, any questions over? No question. Okay, so now we will go a bit deeper about like how do we build Android application. So there is multiple components inside the when we want to build the application. The first one is the activity. So this is the TikTok homepage. So the activity is the container. So when I click on the icon, the OS will it will be like, okay, you want to load this application. I need to show something, right? So I need to tell the program like, okay, we need to start from this container. So I'm going to tell the OS like, if someone click on my application icon, you open this container, and we call this container activity. So we can have multiple activity. So for example, this one will probably be like the main activity, and then it will start. There will be like, okay, we display the view. So this view actually here for TikTok is pretty complex. There's a lot of buttons. And the activity will be, okay, I've set up this view, and then after, like, if you click the like button, this happens. Here there is also a video player, since we need to show the video. So all this will be managed inside the container. Usually we have one activity for one screen. To keep it simple, we can say like this, but we are able to have like multiple view for the same activity. For example, here, if you switch the tab at the bottom, you can make, I'm not saying that TikTok did or did not make this way, but you can change the display multiple view when you switch the tab and keeping the same container. Later, when we build, just very simple, one container, one view, so one activity and one view where I show my list of message plus the input and the send button. So activity is one of the components. Other component is a service. So as I said, we have like a memory constraint, CPU constraint on the device. So when I launch many application, the OS, if I'm not using it right now, it will say, okay, this application is in background. You're not using it. I need some memory. So it will remove my application. It will stop the process. So this can be a problem. For example, if you open your music player and you put the application in background, and now you open another application, you open like the Chrome browser. So if the Chrome browser, then like you open a web page that is pretty big, the OS will be like, oh, this application, the music player that is in background, it's not actively doing anything, right? So I will kill it. Then your music will stop. So that's a problem. And to solve this problem, they come up with this service. So service it's like a container, but there's no view, but it's able to run in background and have its own life cycle. So I can interact with it from the activity. For example, when there's a music, so I can say like, okay, I'm starting this service that will play the music. So the OS will know that, okay, I'm not supposed to kill this because it's not made to be killed to reclaim the memory. Some other is the broadcast receiver. For example, when you turn on the Wi-Fi, internally the OS will broadcast like, oh, the Wi-Fi has been turned on. Anyone is interested by this information or not? If your application Wi-Fi manager, you want to, or for example, if your application is playing video and if the Wi-Fi is off, probably you cannot play anything. But by the time I tell you that, oh, the Wi-Fi is on, so maybe I can automatically retry, and then I can read the information. So for the user, I just need to turn on the internet, and my application will react to this, and then we display the screen or update the information accordingly. The last one is the content provider. means my application is able to provide stuff. For example, if I'm a contact book, if I want to call someone, the OS will be like, okay, anyone have a list of contacts in is able to give me a list of phone number, for example. So here I can register at the OS, say like, if you in case you need this kind of information, I will be able to provide. So there's a list of fixed information that you can provide, and at the time the user requests for this information, they will my application will be able to provide it. Today, we just focus on first one, activity. We don't create any service, broadcast, receiver, or the rest, but just to know that exists. So just to create, so this is the first intent create project. We are going to do it later. I just show you first. There's a bunch of templates that you can use, not to start from zero. So you can create an empty view, or you can even create some view with some just action button to give you some of the basic, just like a kickstart. You just name your project, you save it, and this is how it will looks like. So it will generate a bit of code. It will just generate a hello world. Just for you to, after you create your project, when you run it, you should be able to see the hello world inside your phone or inside the simulator. So we have the directory on the left side and then the code on the right side. So when you create your project, there's a bunch of files that is created. The main activity, activity, as I say, is the container. So main activity right now I only have one, so it's the main one. We have the layout. So as I mentioned, the layout is defined in the XML. So in this case, it's they call it activity main.xml. So it will be the layout. I say like one container, one view. So in this case, they reuse the same name to follow this principle. There's a bunch of other folder. For now, we don't care. And the last one is the Android manifest. The manifest will define all the metadata of my application. For example, like what's my icon, what's my application name, what's the icon, what's the application capable. If you're using the device, for example, if you want to open the camera, the device will show you like, hey, the application want to request for the camera. Do you want to allow this or not? Inside the metadata, I will need to define like, okay, my application at some point it may request for the camera. Previously, all the permission I given. So when you download the application, they will tell you this application can access all those things. For example, you can access your camera, you can access your data, you can access the Wi-Fi. So it was either like you download or you don't download. Now it's like when the user want to do some action, when the camera is necessary, they will ask you if it's necessary. But we still need to declare all the capability of the application inside the manifest. So we will need to change the manifest. For now, everything will be automatically linked. So the manifest looks something like this. It's also XML. XML and Kotlin is the two language that you mostly need to know if you want to do Android. It's very simple. Like you just need to read, right? So they prefix everything with Android just to make sure that you're doing Android. So it's Android, and then they will tell you like what's the label. So the label is the title. So the title here is a Talk Bootcamp, and the application icon support RTL. RTL means right to left. So right, usually for us, I mean, depending on country, some country read from left to right, some country reads from right to left. So there's different way of handling this because all the UI will be flipped, depending how you say it. So here I will define like if I support this kind of thing or not. And a bunch of other information. And you can see the activity, right? So, and the activity has some intent filter. So intent means like the intention. And it said like, oh, it's a main activity and launcher. So that means that the launcher is like on Android, you can define some custom launcher. So the launcher is basically your homepage when you open your phone. So when you click on your application icon, it will scan this file. It will say like, oh, which activity, which container is the one I should use. I'm the launcher, which one I should launch. So here is mentioned, is this activity called Android name? It say main activity. So main activity is the file we saw just now, right? So this for the UI. In this case, so we can just read the first one. So it's a linear layout. So linear layout means it will be linear, like from like either top down or maybe right left. But anyway, it's like a line. And then we have a text view. So it's a view that will probably display some text and a button. This is already quite some good view for our chat page that we are going to build later. We need one button. We probably need some text. So there's some info we can use here. The other information are how is this supposed to behave on the screen? So like what's the width, what's the height, what's the text size, what's the text. So in this case, like the text will be empty text. The size will be 25 SP 20, so maybe 25 something. And the width will be what content means it will be the size of the text itself. And the third component is the main activity, which we already talked a few times. So in this case, the first one will be like which view I wanna set. So it will go set content view, and I will find the layout, and it will after this line the layout will be visible to the user, and then I can find the component on the screen, and I can interact with them. For example, in this case, we have a text view. So I will find this view in my XML that has this ID, and I will be able to replace the text. So this main activity and this activity main.xml, they work together. One will be just the UI, the blueprint, and the other one will define what's the behavior of this view. So each of the view component here has a ID. There's a ID. So the first text view there's an ID called TV title, and the second is button bootcamp. So in my container here, I can find the view that has this ID, and I found the ID TV title. So TV title is referring to the one that is in my XML, and is able to find it on the screen because the line before is set content view. So when the container start, I set the view. Now it's displayed to the user. Then I will find the view and I will say like, okay, this title, now you change. Now the title will be something else. And then the button, when you click on it, it will show something. This is if you understand all of this from this, you will be able to build any Android application. You can build the next application that will raise billions of dollars. This is basically all you need to know to build the application. Everything, all the rest is all custom. It's all like custom views. Just the text is all customized. The button maybe doesn't look like a button. The image, or there's like you can create your own views to display anything you want. So from there, you really have like this is really the fundamental. And after this, you can, if you have any hackathon idea or anything, you can build anything that you want. Yeah. So the next slide is congratulations. So yeah, after this you can run, press play, and this is the screen that looks like the result looks like this. It's very plain, very basic. So we mentioned in our layout, right? It was a linear layout, so it's like following a line. So all items will be ordered, and the first one was a text view. So we have the text, and the second is a button that is displayed below. Okay. If you created any software before, the most simple software you can build is a software that write hello world, right? If you run your first software, so you write all your line of code, and when you execute, you will execute all the code, and then at the end, what's happening? the program is finished. It will tell you completed, I'm done. There's no more instruction to run. So most of the algorithm that you write or the program that you write, you started, you will run all the instruction. When there's no more instruction, you will finish. So in this case, my program is just display a view, right? So if you think from like a very straight thing of how is the software working, by right, it should execute all the line and then it should complete, right? So you launch your application and I'm telling the OS, like, okay, display view, change this button, change that. But at the end, I'm not saying like, okay, like wait or don't do anything. So by right, the application should finish, it should close, or even the entire OS should just shut down. Like it should say like, okay, done. I mean, or else your laptop doesn't know like I should wait for more instruction. So why is the application for Android, when you launch it, why doesn't it close after the instruction that you write is finished? So they have an internal mechanism for this. The long story short is basically an infinite loop. So to manage this, they create something abstraction, which is and then they create a life cycle. So they will tell you like so the program was never complete, and there will be some interaction with the OS. For example, when I launch my application, you will tell my container that has this life cycle. It will tell me like, okay, now I'm creating the container. After it will be like, okay, now I move for example, you press home, you will say, oh, now I move the application to background. So tell me like, okay, I'm pausing the application. Maybe later you will destroy the application. So I will be able to do different things based on this life cycle and based on what's the user doing on the screen. So this what the life cycle looks like. So first is like initialize. So all those methods, they will all be called in this sequence, no matter of what. So it can only be your container. So this is the life cycle of your container, of your activity, right? So it will be on create, so it's going to create. So at this one, I can maybe set like which view I wanna display. Then after it will be, of course, created. Then there's another method which is start. So now it's started, and then it will be resume. After resume, there's no more action until the user like want to kill the application or want to move to something else. Then after it will be like moving back to the destroy state. So it will be like pause, stop, and destroy. So you create, it start, it resume, and thereafter it pause, it stop, and it destroy. So after it's destroyed, means it's finished. There's no more things you can do. So why is this important? If you are playing a video, for example, maybe you wanna start to play the video when the user is seeing the screen, and you wanna pause the video when the user is leaving the screen. So you can play with all those life cycle to based on what's the user interaction to do the thing you want. For example, you're doing some network call, or you're doing some upload of like a very long network call that's uploading a lot of data. If the user actually don't listen anymore and want to kill your application, you can like cancel all this, or like you can interact with this. So yeah, it's linked to the navigation of the user, and they are like call it callback. So just like in your activity, you can just find all those methods that we'll see later. So why do we need? Yeah, as I mentioned, like we can stop video playbacks, stop consuming some resources. We can clear some data. We can basically anything that you can think of that is not necessary. For example, when the user is not seeing the screen anymore, then we can stop all those process. Yeah, so this one is. So yeah, it's also the same as I'm showing every 3 or 4 slides. So now you should be quite familiar with it. So the activity, I need to override Override means I need to use one method that is defined in the class above me. So I see here my main activity is the name of my class. It extend another class which is defined by the Android development kit. So this class is defined above and is probably doing some other thing, but all this I don't need to care. I just need to know that when this method is called, then I will do my stuff. I will set the view, set to interact with my view, configure it, and set my action and so on. So this is the simple version. It can be actually there's a lot of different callback now for the activity. You can be very granular based on the user, what's the user doing. For example, let's not go too difficult. Yeah, when you press back, it can kill your application, or you can just pause it. Android has this back button that is actually pretty tricky to handle, because back button, when you're on the home screen, you actually not move the application to background. It will destroy it entirely. So all this will be handled in the lifecycle, so you can interact with this. Pressing home is another behavior. So all of this will be able to define what the user is doing, and then how we want to interact with this action. So I said like we have one container, one view, one activity, one view. So if we have multiple view, we can have multiple container, so multiple activity. So one activity can start another activity. So we can stack the different activity. For example, let's say I have a form. For example, I want to subscribe to this application. So the first page will be like, what's your username and password. Then there's a button like create account. So the create account, maybe it can be a second screen. And the second screen, so it can be another screen, so another container, another activity. While I move to the second container, I don't need to show the previous one, right? So for the previous one, the OS will say like, okay, you pause this one, I create the new one, I resume, I start the new one, I let you set up the screen. And if I want to go back to the previous one, they will automatically manage those stacking of all the different container. So if I want to exit the like the second screen, which is the creation screen, they will automatically stop, destroy, and then resume the previous one. So today we are not only going to play with one activity, but ultimately, if my application grow bigger, if I want to add like this list and detail page, or if I want to create those different views, I will be able to create with the different activity. So for the activity recap, like some of the key points, is the activity will be the container, and there will be a life cycle with the different method that will allow me to interact with what's the user doing on the device and how is the application currently running on the device. Okay, what time is it? Okay, maybe 10 more minutes before we do the break, and then after we do the live coding, because all this is not just theoretical. You will see later that it actually work. Let's see. So intent. So we talk about activity, right? So I said we can launch multiple activity, but we can tell the OS like I wanna launch this next screen. So for example, the application can say I want to launch this specific activity. I know that I want this one. I want create my account activity. Or I can say like I want any activity, I want any application that will be able to do this specific action. So because those are two different things, they classify into two different intent. So when I want to launch a screen, I will either give like explicit or implicit intent. Explicit will be like, I want this, I know this exists, I want this for sure, you display this now. And implicit is like, for example, I want to make a phone call. So launch any container, any activity that is able to handle phone call. I give you the phone number, you just do whatever you want. So, and your phone has an application that will be able to handle this. Sometimes when you, for example, if you want to share a photo it will ask you like, you want to share with what? You want to share with Facebook? You want to share with Messenger? You want to share with email, Gmail? So this means like I have an intention to share a photo, but many people actually on my device can handle this information because they register in the manifest. Remember, in the manifest we register all the things that my application is capable of. So my if I'm a photo manager, I want to implement a share button. I can either say like, oh, I want this share activity that I've implemented, so I don't let the user choose like from with what they want to share, or I can ask the OS like, hey, if anyone is able to handle a photo, just do it and launch it and tell me when it's done. So that's the both the concept of explicit and implicit. So this is only used when you want to switch from one activity to another. So it'll be we can start the activity. I mentioned activity is not the only container. This can start any container. For example, I can start the service also. So I can have like the intention to play a music. If there's any music player in my device, I will have a prompt like which one do you want to use? You want to use the Google Play Music? You want to play with VLC or something else? Then based on the user input, you'll say, okay, now I know it's this one that you want to launch. So this is how you navigate from one activity to another. So in this case, this is a explicit one. So means like I have the intention, I want to launch this main activity. I don't let you choose like which activity I want to launch. And I can set some flag like what's the, I mentioned that the OS manage the stacking of all those different containers. So I can give some flag, for example, like if this is already launched, you use the one that is in the stack and you move it back to the top, or you can remove it. So all those can be handled into different flag. And then we call start activity and we put and boom, the second screen will be displayed. So explicit and implicit. So explicit is we tell the OS that, oh, I want this one. Implicit is we ask the OS like, hey, which one I should use. Yeah, so this another way of writing the explicit intent where you specify inside your application, because if it's in another application, there's no guarantee that this application is actually installed on the device. So I can say like, I know this exists, so you just launch it. And all my activity are defined inside the Android manifest where I define all the meta information. So the OS will be like, oh, okay, you want to launch this activity? I know where to look at because you tell me in the manifest what's all the metadata. And the implicit is from general action. I said like, for example, create SMS, share a photo, send email or something. So anyone that will be able to edit. So in this case, it's you want to send a text, right? So anyone that is able to handle the send method will be a prompt from the OS. So in this case, it will show you like Gmail, the message application, and so on. And then I will pass them as parameter the text that I want to send. And then after it's up to them is outside of my application. Yeah, so for example, here I want to make a phone call. So let's say I took a Grab just now. It was very lost in the campus. And there's like an emergency button. The emergency button is calling their call center. So you can maybe they have something that is built internally, or then it will be explicit, or maybe it will just open the specific phone number, like an emergency phone number. And in this case, I can tell to the OS like, okay, I want to start a phone call, and this is the phone number. So the phone number need to start with the phone number. So it will be it will ask you all my different applications that can make phone call or that they define in the manifest that they are able to make phone call. There's actually no guarantee that they will be able to do the phone call, but just that they say so. So the device will, the OS will just prompt all those applications, and then it will launch it with the parameter. Oh, now it's the break. It's quite fast. I think we can do the break now. Oh.
What do you want to do? I can help you.
No, I just want to check if the recording is on. But we have that one. So.
To get it from our corner. Yeah. But is that okay? Yeah.
Okay. 7:31. I have. Wait. Because it's a multi display, like how do I do the mirror? Because it's like it's a display as a second screen. Yeah, just now it was okay.
Like go to the
Wait,
PowerPoint first.
display option.
Did you use this display option just now? I think we just try the PowerPoint page.
But I think it's when I put play, it will display everything. Oh, I put the screen mirroring to because right now it's like two display. Arrange. It's because all the screen here are like an additional screen because when I work I have like this two screens, so it's like I want to have the same screen here as the one on the.
Oh, okay.
There's a display. I've never seen display. Arrange multiple, no.
Let me.
Oh, I don't have internet.
I can log in for you.
Oh, is it connected?
Okay, I think this.
manual here. You want to follow? Maybe describe.
Yeah, I'm inside the display already.
Okay, then is there? I think mirror.
Just pop up. Oh, mirror.
Mirror, yeah.
Oh, okay.
Does it work?
Yeah.
Okay.
Okay. Can you log me for the?
Okay. For now, I can use my.
Oh, no, it's okay. I think I will do. Maybe it will work. It should work. Oh, you want me to join as guest? It's okay. I'll see later if.
Okay.
Okay. I think we can start again. So today, so now I'm going to show you how you can create your activity. So there's always a demo effect when you try to do something, it always doesn't work. So let's see. I don't want to set the expectation very high. So let's see what's the problem we may face when we create the project. So I have the Android Studio here. I already have a bunch of projects. So I've seen a couple of you have already downloaded the software, which is good. So the first thing I'm going to do is I create a new project. So all of this we saw it in the slide. So I'm not going to repeat. But here we have like different template we're gonna use. For today, I'm going to use the empty view activity. So means like I will use a container which with an empty view. And then later we are going to create the view and interact with the view. So the first thing is the name of my application. So I can call it I can roll, which is I think the name of the workshop. The second thing is the package name. So if you're familiar with Java works with like a package structure. So here we will define like what's the different package you should use. So this is mostly for the folder directly. But this package name will also be used as a unique ID when you want to upload your application on the Play Store. So if you open the Play Store on the desktop, when you see the URL will be like playstore.com/ then you will see the package name of the application. And the package name is defined at this exact one, and you cannot change later if you upload your application. If you want to submit a new version as an update, it need to be the same package name. So I'm going to use Kotlin. And I talked about the fragmentation earlier, right? So I said like which version I want to use. I'm not sure if I think this screen is broken today because I also tried to load earlier, it doesn't work. Normally here they show you like what's the different, how many users are using this version. So since the version is retro compatible, so it means that if I target Android 11, it will work on Android 11, 12, 13, 14, and all the version above. But it won't work if the user is on Android 10. So it's like you need to be on this version or higher. So here by default it say Android API 24, Android 7.0. So they have like the version name and they have the API version. So sometimes they release some new API version and they don't want to increment. I would say one is for the developer and one is for the public, where they want to announce, oh, this is the new Android 14. But for the engineer, Android 14 is actually API level 34. So it depends like for the marketing or for the engineer. So here let's say Android 7.0. I think my phone right now is like from 3 years ago. It's I think running Android 13, which actually is the second latest version. So Android 7.0 is actually quite long ago. So I think it should be okay to start. Oh, you say we can have 96% of the user. I say there is like 6 billion mobile user. Maybe 70% is on Android. So here I will be able to target 96% of those users. So you can count how many billion of potential user I have. I'll finish. And from there, it's going to create the project, set up all the configuration. So the first thing that you open, we see is my activity. And there's only a few lines. So activity, remember, is the container, and the onCreate is the life cycle. So here's like my container is created. Then what should I do? And there's one line that's already there. It's like set the view, and you already create one view which is hello world. So here the view is double. One is like what the user will see, and one is the blueprint. Sometimes we have like multiple view on top of each other and stuff. So to see what's happening, they created this blueprint. You have a bunch of tools to create the view, to add some more items. So what we are going to do now is I'm going to go on the simulator. So the simulator is this button, device manager. From the device manager, I can create a new device. So I have like a physical, virtual. I will create a virtual one. And he asked me like what model do you want, because the device has different screen size. So if I want I think now they even have like foldable device, right? I don't know if the simulator actually have this, but like if I want to test, for example, on the small device, if I want to test on a bigger device, if I want to test on the tablet, I can select here like what do I want, or if I want the watchOS, Android TV. Android TV is another problem. So I would say a phone. So they will propose me all the Pixel, because Pixel is also made by Google. Everything is made by Google here. So I can set Pixel 4a, so the screen is 5.7 inch. So I already create two devices here. So this is a Pixel 4a on API level 34. I mentioned just now, I think 34 is the latest Android 14, so this will run on the latest version. I can launch the AVD Android virtual device here, or I can run my application. So this is my application. It's called app, and so my application, and then where do I want to run it? And then you will say, oh, I want to run it on the simulator. If I plug my phone here, if I put the debugger mode, my device will be visible here, so it will directly install the application on my phone, assuming that I have an Android and not iPhone. So yeah, and then I will press run. So here, a lot of things going to happen. You see all the windows are blinking. Okay, now it launched the. Okay. So it happened quite fast because the application is very small. It's only like, as you can see here, it's only like few lines of code, but it's still there's still a lot of things happening inside my application, just to display this very simple hello world. So this hello world here, that is the activity. So this is the activity. This is my blueprint on the left side, on the middle. On the left side is what the Android Studio tells me. This is what you're going to get if you run your application. And on the right side, the window. This window is an actual Android. It's an Android simulator. So it's almost like an actual phone. And actually, what we have is similar as what we are expecting, which is good. The application did launch. It didn't crash. So maybe you don't trust me. So this is the actual Android device. So this is my application, so I can swipe it. So yeah, this is really Android. I even have the Play Store. I can install any application. You can use this as a sandbox. Let's say someone. Lately, I see in the news there's a lot of people like they want to buy something that is cheap, and then they talk to the seller and they'll tell you like, oh, install this Android application, and then you transfer me some money, and then The next day they found out that their World Bank account has been hacked, and then all their fund has been withdrawn because of those suspicious activity. What you can do is, what they are sending you is the APK, the application package. It's the final zip of the application. You can take it, you can install it on this simulator. This one has nothing, and you can see what this application is doing. And here we even have like a bunch of things here. We have like the logcat, so this all the log. So from here, the device actually is printing a lot of things. It's printing everything that it's doing. So if I launch my application, it will tell me like, okay, I'm launching this application. So from there, if I have a bug in my application, I can use the debugger. Remember, we saw the debugger screen, which is also one of the tools that I can use at the bottom. Or I can also print in the log. The log can also be used because we can record the log. And for example, if we have like a bug report system, we can use those last log that is recorded. We can like upload it along the bug report, so it can help us to find the bug and to find what was the problem. So this is a actual device, so I can open the Google Play. It's quite hard to do the gesture on this small screen. I can open the browser. I'm stuck in the onboarding. Yeah. So there's like, I can literally browse the internet, but my laptop is not connected to the Wi-Fi right now, so it won't work. Okay, so another thing is we have photo, camera, we have like the location. So the device is able to do a lot of things. So this is the camera. If I'm doing a camera application, or for example, if I'm doing an application that is allowing the user to record some video or to take some photo, we need to access the camera. If I don't have any real device, how do I test? So this simulator come up with, in this case, it's like a fake. It's like an image that is moving. So at the same time, if you take photo or video, you will see that it's animated or not animated, and you will see whether it's blurry or not blurry based on how many frames are you recording. So they will simulate a bunch of things. So I can also simulate what's my location right now. For example, if you are doing a location-based application, I can even simulate that I'm moving from the point A to point B. If I'm doing, let's say, like a GPS application. So with the simulator, I should be able to build and to test most of the application. They may have some performance issue because this is not a real device. It's still running on your machine, but at least for the very simple application should be no problem. So here, let's go back to our code. So we have our main activity. So as I said, like we are going to build a chat page, so a list with input and a button. So we have 3 components. So I'm going to open my activity. I can use command click to navigate directly. From there, I can either edit the code. So the code is automatically updated on the view. So if I comment this, my view is gone because this code is removed. So it's there, boom, update. If I delete, it's gone. So by almost real time, I will see like what's my user interface supposed to look like. So if you're working on some company, normally you have a designer that is coming and will show you some design. Normally, first thing, you will be like, how am I supposed to implement this? Because they are coming from designer background, not from like, this is how to do the specific. But your job is also to figure out how to build those complex UI. So in this case, I didn't come up with a blueprint, but let's imagine some very basic messaging application. So the first thing I will have, so I will use some of the components I have here. So the first one is the text view. You see, I have like this palette. So they come up with like some very basic component, like the radio button. Maybe I can zoom a bit. No. Yeah, maybe it's a bit small, but like, so I can drag and drop. For example, I have this button, I take it, so the button looks like this, and I will put it right in the middle. If I want another button, I take it, it's there. I want like a checkbox for my phone, I have a checkbox. So the checkbox will be like click, not click. I want a radio button. So this, like if I have a different form, so this all the different component I can add. I can also create my own component. If I use the text, they have multiple text, but the first one is the plain text. We can see that this is they call it text view, but I can open the class. So ultimately, everything is Java or Kotlin code. In Android, mostly everything is written in Java. So this is the class that is provided by the development kit that I'm going to use. That is doing all of this. So this all the capability. This will define how does it draw? How does it? For example, if I want to change the color of the button, everything will be defined here. So this is written directly and it's available inside the Android SDK. The class is like 15K lines of code, which is small or not small. It depends what's your relative. I think the class is pretty big, yeah. So there's like this class to manage the text view. There's like 15,000 lines of code, so there's a lot of capability. It sounds like it's just something that displays text, but actually it can do a lot of things. So I can configure it here from the XML. So in this case, I say like the text, it will be text view. So by default, the text view will be here. Here, if I change like hello to I can roll, so it will update. So because inside this class, inside this text view, it will check what's the parameter I put here, and it will say, okay, you put the text is this, so I'm going to draw this text. I'm going to display this on the screen. How does it display on the screen? I don't care, and I don't know, and I don't care, because that's his responsibility. I just want to use those components. So when we do software development, we mostly reuse component that is already existing. I can rewrite everything, but it will be very buggy. It will take a lot of time, and someone already done it better than me. So I should just use everything that already exists. So first thing, when someone asks you to build something, check if this thing already exists, and it will save you a lot of time. I think this applies to any project that you can build. Everything is available on GitHub. Check the license. If it's free to use, just use it. It's probably going to work much better than anything you can build in this period of time. So here I have my text view. The ID is called text view. So because I don't like when everything has the same name, so I will just say the ID is called text view _ID. So I say that the activity and the layout and the XML can talk to each other, right? So in this case, it's called set content view. So this method is defined in the app compat activity. I don't need to know how they actually display the screen. What are they doing with this layout? So this means like I want to set the content view. So I'm calling this method that exists in some class higher in the class hierarchy, and I will pass this reference. So this R means resources. Inside the resources, because resources can be like layout, it can be an image, it can be some other stuff. So I will tell you inside the resources it's a layout, because I define here inside the resources, you see rest, right? And then there's like drawable, layout, bitmap, values, XML. I can define, like, for example, different language, different string. If my button is called hello world, maybe in other language, I can define some other variant. So all those will be like resources. So there's like a layout, but we saw that there's a drawable, right? So I also have r.drawable. So drawable, I can access everything that is inside the drawable folder. So the layout, I only have one, which is the activity main. So in this case is layout, and there's autocomplete activity main. There's also order that is suggested here that is available inside the SDK directly. So when you since they come up with a lot of things that you can use, there's things that you are creating, but there are also things that the the development kit provide to you. So you can also use this directly from inside your application. So in this case, I have my layout, and I will split the. I'm going to split the screen. So for now, I don't need this, and so now I have three things. I have my my container, my activity. I have the XML of the. So I have my views, and how is my view supposed to look like? So I said like the view here is called text view ID, and it's a type text view. So I'm going to find this view. So my container, after setting the view, was like find this view because I wanna do something. So I'm going to do find view. So there's an autocomplete that's very useful. So every time you write something, you will try to see like, oh, maybe you want to use. You will try to predict what do you want to use. In this case, there's a method that exists, which is called find view by ID, and you expect an ID. So you expect two things. You expect like what's the class type and what's the ID. So all the ID are defined in the resources. So I mentioned just now the resources we access with this shortcut called R. So R dot I say it's an ID, and ID he already proposed me because it's probably the only ID I defined in my project is TextView ID. So this TextView ID match this TextView ID. If I rename this to TextView ID 2, now it become red because it tell me like, oh, this doesn't exist. So if I try to run this, either it won't allow me to compile because it knows that it's an error, or it will crash at runtime. So I'm just going to call it TextView ID, and immediately you update it and say it's okay. Now it become green, and I can navigate. It will link from one to another. And if you're familiar with Java, this is a generic type. So he expects something. If we see here, he expects something that extends view. So view is a generic class. So everything that is drawn on the screen is a view. Everything is a view. The text is a view. The button is a view. You can have like anything. So he wants something that extends view. So in this case, it's a text view, right? They even give it in the name. So I would say the type is a text view, and yeah. So now I have access to this. So I can assign my. I can assign my my view to a variable. So I will call it, for example, my text. Okay, so now I have my text view. And if I want to call some method on this, the method that is available is all the method that is in the super large class we saw just now, the text view, right? So the first one he proposed me is set text. So for every text view, you want to set the text. So we saw from the XML I can set the text. So when it's first render, it will show this text. So in this case, it will be hello, I can roll, right? But if I want, I select this, I remove it. So by default, it won't show any text because I don't set anything. But I want to set it from the code. So I will say I set the text, and the text is hello, I can roll. So here there's a bunch of warning because he told me there's a better way of writing this, and the better way is to use .text equal. It's also unhappy because the text is hard-coded, so means like on different language, it will show the same text, which is probably not something that you want to do. But in this case, it's just a warning. I will say I don't care. So I can look at the method inside the text view. So they have a method set text, which take a char sequence or a sequence of char, and then they will do something, and it will be displayed on the screen. So normally here, if I run, where's my simulator now? It's my simulator. So I press play. So what I did just now is like from the view that was displayed. So maybe you don't see it, but it's far at the top. The text size is very small. So so now I'm setting the text from the code. So I can put like set text size and put it bigger. One of the things that we didn't put in my introduction is how do we manage size or measurement on Android. One of the problem is I cannot say like I want the text to be 20 pixel. I think if you are doing, if you're familiar with the computer and stuff and software engineering, mostly what we use is pixel because your screen is able to display this by this pixel. The problem is like we have so many different devices, so they come up with a number that will match to how many pixels are there on the screen per inch. So some screen they are like a very high definition, some screen are lower definition. So here they will allow me to define like this this measurement. So in this case, for now I don't care. I don't need to put the text bigger. So this is my text view. So now I can just build my user interface. So now we'll do something more complicated. So I remove this. I keep this container. So here by default it creates a constraint layout. I think in the slide just now the container was a linear layout. So we need a container for the view. So the view is a tree. So you have like one parent, multiple child. Each child can also be parent of some other child. And at the same time, you have like this tree of view. So this find view by ID will start from the root, and it will do search inside the tree. So if you are familiar with tree algorithm, you can probably guess how is the find view by ID implemented. So I think by having also those like common algorithm knowledge, you'll also be able to guess how's the data structure and how they're going to navigate through this data structure. So I can change this constraint layout to linear layout, but in this case I will keep this constraint layout. Constraint layout allow me to set constraint on views, which means that I can arrange the view compared to each other. So I mentioned that we want an input, right? So I'm going to get the. So I want a button which will be my. So it will be my send message, and this will be at the bottom of the screen. Usually it's somewhere around here. So I can move it like absolute position, but because of the different screen size, this is a constraint layout. So I'll say like the right. You see, I can move. I can say like the right of this button is constrained to what? So I will say it's constrained to the right side. And for example, the left, I can say is constrained on the left side. So now my button is center because my button, the size is the width is wrap content. Wrap content means is the size of the content itself. Or I can do, you match the parent. So matching the parent, it would be like the size of my parent container. So now my button is very big. Can use wrap content. So, and I said like the end of the button is constrained to the end of the screen, and the start of the button is constrained to the start of the screen. So if I apply those constraints, I start at the left, I end at the end, and I'm the size of the button, so it means I'm in the middle. There's no other choice. So I can do the same thing for the top down. So I can say your constraint at the top, and at the bottom there is no constraint, so it will be all the way at the top, and I can just drag and drop, and then now I have a button that is on the middle. This button will be on the middle in any screen device, any Android device you can get, like any Fold device or like any different screen size. It will always be in the middle because I set it as a constraint. So this is solving quite a lot of problem on the different device size and so on. So in this case, I'm going to remove those constraints, and usually what those messaging application looks like is like the button is like at the bottom right. So it will look something like this. Just to confirm, I can run, and because I removed my I remove my text view from the layout. Now I cannot compile because just now I was setting the text view, so I'm going to delete this line because I have no more text view to display. And boom, I have one button here. Yeah, so I have a button. And you can see when you click, there's some effect. So all those, of course, all of this is customizable. All the button that you can have on Android probably extend this base class button with a lot of customization. So I need another thing is the input to key in my message. So I'm going to go back to my layout, and this time I will pull it from the code. So there's a text input, edit text input layout. So I will use edit text. So the width. So I need to set a ID. So in this case, the ID will be input text, and this is the button. So my input is here. I will move it at the bottom. I will constrain it here, and then at the end, it will be constrained to to this button. So here it will say like there's a conflicting way of doing things. It's like I tell you that your size is the size of the parent container, but at the same time you need to be constrained on the right and on the right side of the button. So actually it's kind of like impossible. So in this case, it will just use all the entire screen size. So I can, if I'm not mistaken, I can tell him that the width, I don't tell you what's your width, you just follow, this time you just follow what's available on the screen. So I put 0 dp. dp is the measurement that they created to allow display based on pixel density. So if I put the width here, I won't put like, for example, 100 pixel. I can put 100 pixel, but it won't work it will only display strictly 100 pixel. So you take a phone, you count 100 pixel, this will be the size of your button. If you take the latest high-end device, 100 pixel is probably as small as like maybe 1 centimeter, or even like, I don't know how many pixel per centimeter there is on the screen. If you take a very low-end device, maybe 100 pixel is the entire screen. So it's not very reliable. So we need something that is based on what's the device specification. So they come up with this called DP. So in this case, if I say it's 100 DP, or there will be, let's say I put 500. So 500 in this case is bigger than the screen that is defined. So I can hardcode my button to, let's say, 200. I'll put 150. Yeah, maybe it looks. So it looks like this. So now I have one button. I have one input. So my send message is here, and the input, when I click, the keyboard already open. So this is the Android keyboard. So, and I can type my message, and I can send my message. So here I already have 2 of the 3 components I need to build the screen, and the last one is the way of displaying the list of the message. So all those, you see, I didn't do much code. I even didn't write any code in Kotlin. I just built my user interface, and because the OS say like, okay, this is a button, so there's like this effect, this is an input, so when you click on it, I open the keyboard, and then it will automatically add, I can even write on the keyboard here, it will automatically display, the cursor icon is also display, the cursor will also blink every 1 second, all this is automatic. Just by using those components, they will handle a lot of things for me. And the last component that we need is, we call it recycler view. So now it's going to be quite a bit more complicated. So we have this component that will allow me to display multiple views. So if you're using some of the messaging application, you see the list of messages. So each message, let's say it's a view, or it's even many views because the message can be complicated. You have like the message, but you also have like the sending status of the message and so on. So to avoid bloating the memory, they come up with this this custom component called recycler view. So the view will be recycled to be reused. So after it's created, it will recycle it when you scroll. So the view that is outside the screen, it try to recycle it for like the next one. So it's like rotating of the view. So I only create as many views as I need to be displayed on the screen. But after I fill the entire screen, I will when you scroll, I will just remove the view and then recycling the view. So I'm going to put this. I will fill the rest of the screen with this, and the width is match parent, and for the height, I will just say you fill the rest. So now I'm done with my user interface. So it looks like this. So right now there's no message that is displayed, but we can see there's already a component here that will be filled. So now I need to set my container. So I don't care about the simulator for now. So I will find my view. So I will find my view, which is the button. Sorry, the button, and the ID. The ID is here, right? So the ID is called button, and I will just call it button. So the button has some action. I can set on click listener. So when the button is clicked, I can listen to it. So this is a callback. So here, this code that is inside this block here will only be called if you click on the button. So for example, so here I can access. So this is a callback. I can access like what's the message that is currently written. So I will need to find another view. In this case, it's text input edit text, and the ID is input edit text, and I can assign to a variable which is called input text. So what I'm doing here is like I'm finding the view input text, I'm finding the button, and I tell the button when someone click on the button, then what I do. So I can access this input text, and I can call I think there's a get text. So here, when I click on the button, I will know this is the text that is currently inside the input, and I can interact with the input. I can say you set the text to empty. For example, when I send my message doesn't stay in the input, right? My input is updated and my message is gone. So in this case, I will put in my input. I will write hello. And normally when I send, you see my input gets clear. So I write, when I send, it's clear. So in this case, it's like you can say it's sent. So I have like interaction right now between my input and my button. But the text I have written is not lost because I've stored it first before I erase it. So now I'm going to create a database for all my messages. I can use the very simple data structure. I can just use a list. So my database will be just a list of messages. So we'll just call it list of messages, and it will be a. So it's a value or var. Value means like a immutable. Var means a variable. So in this case, it's a immutable variable of list. So it's a list of strings. So this is my list of message. By default, is empty, and my list of message. When I click on the button, I will add whatever what was there in the input. Now it's not happy because the type mismatch. It's editable and it's nullable. So I will just convert it to a string. And there is one problem that can happen is like, what if you click on the send button and you didn't key in any input? Means like it's not empty, it's null. So what should I do? So in this case, how do I handle this case? So I can check like if the input, so I select this, if the input equals to null, then you stop. So I can assign it to a variable. So this is the input. So if the input is null, you return the callback. So all this code is only called when I press the button. So in this case, I say like, okay, if this is null, you stop. In this case, it tells me there's a better way of writing it. It's like you take the text, or you return immediately. So in this case, now I have an input, and if I check, the input is editable, and it's a non-nullable editable. I can guarantee that there is something. Maybe this something is an empty string, but at least it's not null. So I can just add the message, and then I clear. So in this case, when I click the button, I will get what's the input. I will add it to my list of messages from my conversation, and then I will clear the input. Now we need to display this on the screen, which is the recycler view part. So for the recycler view, I'm going to find it. So I'll just call it also recycler view. So the type of the class that I defined here is this class. So this is the package name, right? AndroidX.recyclerview.widget. This package is like com.example.icanroll. So here I can retrieve the package, right? com.icanroll, and then if I define a custom view, I will be able to use it here. So this recycler view at this package. So this recycler view here. So the class is the same, and the ID is here. How I access the ID, resources ID, recycler view. I assign to variable, and now I have this recycler view. So I have this variable, that is the type, recycler view. In this case, there's like something, it's not happy because I haven't recompiled, but now it's okay. And it's display. Nothing has changed. Normally, it shouldn't crash. We'll check later. So I want the view to be able to display multiple messages. So for this recycler view, it works with one design pattern, which is called the pattern adapter. So this will recycle the view, and it will tell me like how you should. So I will define some view, and it will tell me like how you should display those view on the screen. So first of all, I will give him a layout manager. So this one, the recycler view can be displayed in multiple ways. It can be vertical, it can be left, right, it can handle multiple things. So I would just define this. For now, this one we don't focus on it. So I will set the adapter. And the adapter here, if I look, the class is called adapter, but it's inside recycler view. So it's a recycler view adapter. So I'm going to create anonymous class here, and okay, the autocomplete. Where's my adapter? Okay, I will create as another class, so I will call it my adapter, and it will be a recycler view.adapter. Oh, it's because you want a type. So the adapter can adapt on different types. So in this case, you want a view order. So we are going to define the view, and the view will be held by something. So when I'm going to recycle the view, there's something that will hold the view. So this things that will hold is a view order. So I'm going to call another class, which is my view order, which extend the view order. And in this case, you want a constructor. And what you want the view, of course, you want the view to that is be able to be held. So I will pass it as a parameter. So it will be like the view. I will just import. I'll pass it as parameter. Yeah, so that's it for my view order. And now I need to implement 3 methods: on create, on bind, and get item count. So this part here, I'm going to use it inside inside here because I wanna be able to access this list of message directly. Here is another class, so it will be quite troublesome. So okay, everything is working fine. So now I have my recycler view. I have a layout manager, something that will manage all the layout, and I have the adapter that will tell me to create. So in this case, I'll create the view. So I have the parent, the view type. The parent is the container. So in this case, it's the recycler view. So I will just take I just want one very simple text view. So the text view is the view same as defined here, but I can even create it. I can create the class. This is a new text view. I instantiate this class. So from the class, which is the blueprint, I want the object. So I do new of the class, and I get the object. You want the context. Context is something that is quite specific to Android. We don't need to care right now. We just the container is also having their own context. So I can pass this of the container to tell you that okay, the context that you're running into this is inside this container. And what I want is a view order, right? So the view order is the one that we define below. So in this case, the view order, I pass the argument the view, so it's a text view, and you will hold it. The get the item count is the list of messages. So I will just return list.size. And onBind means I have like this view order. Now you need to adapt this data to this view. So I have everything I need. I have the list of message. So I will need this. So which one I should access? I access at this position. So now I have a message and I have a view order. And this view order, I will be more specific because it's only a text view. So I will access the view order, the view, and I will say the text is this one. And they say set text, we can change to dot text. So now a lot of things have happened. I went quite fast. This recycler view, you will see, will be able to see the multiple view on the screen. I'm not sure exactly how the basic text view by creating like this will look like. Not sure what's all the default value, but let's try to run this. So there's one last thing that is missing is when I change the list of message, how do I tell the view to refresh? How do I tell that the data has been changed? So this is through the adapter. So I'm going to access as a variable. So this is my adapter. So in the onClick, it will add, it will reset. Then I will tell my adapter, hey, I want to notify you that the data has changed. So I call this notify data set change. This means like something has changed. I don't know why. Just recheck everything. So it gave me a warning, say this may not be the most optimized way of doing things, but right now I think it should be okay. So if I run it, so first of all, it didn't crash, which is already quite good. So I have my input, I can key in, I can say hello. So normally when I press send, it will add to the list of message, notify the adapter. As I mentioned, I don't know how the view looks like. Yeah, so the view has been added far at the top. The view has been added here. So this is my text view. So if I send multiple messages here, you see it will always add below. And this, you see, I can drag the view. So if I reach, since this is a multi-line, if I send, I will be able to scroll those. Yeah, so this is my conversation with my list of messages. It's maybe you can see from the screen that is close from you. You see, I can drag the screen and I can scroll the list of messages. This is a very basic text view because I just created. I didn't set what's the text size. I didn't set what's the font, what's the color. I didn't set any line separator. So of course I can create some view that is much better than this. But here, it already give you the basic idea about like, you have the container, you have one blueprint of your activity where I have like 3 components. I have my list of messages, I have one input, I have one button. When I click on the button, I need to update my database. So in this case, I also have a in-memory database. So this database will be destroyed when my activity is killed, right? One thing that we can do also is to play with the life cycle, right? We say we have like a on destroy, on resume, on pause. So for example, when I on pause, I can clear my list of messages. So if I send one message, it will display on the screen. But if I move back, on pause will be called. So in this case, it will clear the message. So what's going to happen is like when I'm going to go back, here, it's gone. Because my database has been cleared. Actually, I'm surprised you update here without calling the notify dataset change, but it's okay. Yeah, and the recycler view is a bit, I know it's a bit complex to explain in like a 45 minutes workshop, but mostly if you use any application, everything that you see in the application is mostly a list of something. If you see, imagine this, the message here is very small. Imagine the message is the size of the screen, and then I can scroll to the next one. That maybe reminds you of some infinite list of video, or infinite. There's a list of things like everything that you see is mostly a listing of different things, and they all, I can tell you on Android, they all be based on this component. So by using those recycler view, by using this text view, edit text and button, from there I can already build 99% of the application. It will require a lot of customization because right now it looks very plain, it looks very ugly, but with all the customization I can make this really looks like a actual messaging app that people want to use. Yeah, I think that's all for me.
Does anyone have any questions for Lucas? If you have, just raise it up. No worries, or you can also come and approach Lucas.
Yeah, I'll be here for a while. If you want, we can, yeah.
When we were choosing to make an emulator, why did only some of the options for phones have the PlayStation icon next to them?
Yeah, so some of the devices they will come up with the Play Store already installed. By default, on the past, they actually never come up with the Play Store directly installed on the device. So all the simulator were not having the Play Store. This was causing some problem because the Play Store is doing a lot of things. For example, you cannot run Google Maps if you don't have the Play Store installed on your phone. So if you want to use some of the Google services, you need to have the Play Store installed. So to solve this, they come up with some simulator that, on top of that, they also come up with the Play Store to solve this.
So before you leave here, please come and grab a brochure from Tim.
Okay, thank you.
We want to share like this feedback form. So can we unplug?
Yeah.
Thank you.
Before you leave here,
Is it here?
scan the QR code, which will be shown later. It's the feedback for today's workshop.
Thank you very much.
Yeah, no worries.
It's not showing, is it? Okay, let me just reshare again.
If you're able to send the slides to us,
I need to check with the
problem.
resources first.
if it's
You want one? Oh, thank you. You just unplug.
Anybody else needs a brochure? Okay.
Oh, thank you.